Imagine that one day, on an ordinary day, the most sensitive ears of humanity picked up a whisper from the depths of space. This happened on May 15, 2015. The giant RATAN 600 radio telescope recorded a short but unusually powerful burst of energy from a star similar to our Sun. The signal was so strange that it was classified for 2 years while scientists tried to understand its nature. What was it? A technical glitch? An unknown phenomenon? Or the first meaningful signal from an extraterrestrial civilization? We will tell you the whole truth about the signal that for a moment made the world believe that we are not alone. Far in the south of Russia, in the Republic of Karachay-Cherkessia, at the foot of Mount Pastukov, lies one of the most amazing creations of engineering thought, the RATAN 600 radio telescope. Its gigantic, nearly 600-meter ring of aluminum shields gazes up at the sky, listening to the silent symphony of the universe. This is not an optical telescope. It does not see starlight in the way we understand it. Its domain is radio waves, invisible echoes of grandiose cosmic processes coming to us from unimaginable depths of time and space. Here, at the Special Astrophysical Observatory of the Russian Academy of Sciences, astronomers keep their unhurried watch, scanning the sky in search of anything that might disturb the cosmic silence. May 15, 2015, was one of those ordinary, unremarkable days. The telescope was methodically scanning a section of the sky in the constellation Hercules when something extraordinary happened. Computers detected a short but extremely powerful burst of radio waves. It lasted only 2 seconds. The signal came at a frequency of 11 gigahertz, or, if converted to wavelength, 2 and 7 centimeters. For the average person, these numbers mean nothing, but for radio astronomers, they sounded like thunder on a clear day. The signal's power reached 750 million. This is a huge amount by radio astronomy standards. The source of the signal was in the direction of a star, known by the dry catalog number HD 164,595. The scientists' initial reaction was bewilderment, followed by cautious excitement. In radio astronomy, 99% of all anomalies turn out to be terrestrial interference or equipment errors. But this signal was different. It was clear, narrowly focused, and very strong. It was not like the chaotic noise of a quasar or pulsar. It had signs of being artificial. It was as if someone at a great distance had turned on an incredibly powerful transmitter for 2 seconds, pointing it directly at Earth. The news of the signal did not immediately become public knowledge. In the scientific world, it is customary to double-check data multiple times before making bold statements. Scientists led by Nikolai Bursov began a painstaking analysis. What was it? A previously unknown astrophysical phenomenon? A malfunction in the complex telescope equipment? Or, and everyone dismissed this idea, afraid to believe it could be true, was it the very signal that humanity had been searching for more than half a century? The first meaningful whisper of an alien intelligence. For 2 years, the data remained within a small circle of experts. They searched for repetitions of the signal, analyzed its structure, and tried to find a natural explanation for it. But the signal remained silent. It came from the abyss once and disappeared, leaving behind more questions than answers. This was the beginning of one of the most intriguing and controversial stories in modern astronomy. A story that for a brief moment made the whole world believe that we are not alone in the universe. The signal was just a guest, flashing across the radio telescope. but its supposed source, the star HD 164,595, remained in place, silent and majestic, as it had been for billions of years before. To understand the full depth of the excitement that gripped the scientific world, one had to look at this star more closely, not at its radio ghost, but at its physical essence. And when astronomers did, their interest only grew. 164,595 is not just a random point of light in the constellation Hercules. It is almost an exact copy of our Sun. It is classified as a G2V spectral class star, the same as our home star. It has almost the same mass, the same surface temperature, about 5,800 degrees Kelvin, and the same yellowish-white light. Its age is estimated at 4.5 billion years, which remarkably coincides with the age of the solar system. Even its chemical composition, known as metallicity, is very similar to that of the Sun. This meant that the protoplanetary disk from which it was born contained enough heavy elements, carbon, oxygen, iron, to form rocky planets similar to Earth. It is located 92 light-years away from us. That doesn't sound so far away by cosmic standards, but it's a deceptive impression. The light we see today left that star in 1933. If we sent our fastest spacecraft, Voyager 1, it would take more than 1.5 million years to get there. We were looking at it not just through space, but through time. Moreover, this star was not alone. Observations have shown that it is part of a binary system. At a huge distance from it, about 2,000 times farther than Earth is from the Sun, a dim companion, a red dwarf, orbits. This is a small, cold star that could not have prevented the formation of a stable planetary system around the main, Sun-like component. And there really was a planetary system there. At that time, at least one confirmed planet had been discovered around HD 166,595. HD 166,595. B, however, it was not at all like Earth. It was a hot Neptune, a gas giant about 16 times the mass of Earth. It orbited very close to its star, completing a full rotation in just 40 days. Its surface was scorching hot, making any form of life as we know it impossible. But the presence of even one planet, however inhospitable, was a good sign. It confirmed that this star had a planetary system. And if there was one planet, there could be others orbiting at more comfortable distances in the so-called habitable zone, where water could exist in liquid form. Thus, the ideal picture for seekers of extraterrestrial civilizations had emerged. A twin of our Sun, almost the same age, with a proven planetary system. It would be difficult to imagine a more suitable candidate for the home of our brothers in mind. That is why a single powerful signal from this corner of the universe caused such a storm. It did not come from a random place, but from a system that seemed to have been specially created for life to emerge there. For over a year, news of the mysterious signal remained the preserve of a small circle of Russian astronomers. In science, it is not customary to rush to sensational conclusions. Verification was needed, additional time on the telescope, the writing of a scientific article, and its publication in a peer-reviewed journal. This is a long and painstaking process that ensures that the scientific community is not misled by hasty conclusions. Scientists from the Special Astrophysical Observatory were preparing a report for an international astronomy conference to be held in Mexico in September 2016. But in the age of the Internet, keeping such potentially explosive information secret is virtually impossible. On August 27, 2016, the dam burst. It was Paul Gilster, a respected science journalist and author of the popular blog Centauri Dreams, dedicated to interstellar research. Gilster received information about the signal from one of the astronomers and, after contacting the research team, obtained permission to publish. It was a difficult ethical choice. On the one hand, scientific rigor demanded waiting for official publication. On the other hand, news of this magnitude seemed to belong to all of humanity. Gilster published a detailed article in which he outlined all the known facts, the power of the signal, the characteristics of the star, and a possible explanation using the Kardashev scale. He was cautious in his wording, emphasizing that an Earth-based origin for the signal was still a likely explanation. But the genie was out of the bottle. Gilster's article was instantly picked up by the global media. Within hours, the news spread around the world. Signal from Sun-like star system may be the work of extraterrestrial civilization, wrote the British newspaper The Guardian. Astronomers detect intriguing alien signals from star, echoed the American television network CNN. The headlines became increasingly loud and sensational. Journalists omitted the cautious reservations of scientists, focusing on the most exciting part of the story: possible contact. A real information fever began. Social media exploded. Thousands of people, from professional astronomers to ordinary space enthusiasts, discussed, argued, and built theories. The hashtag #164595 became a top trend. For many, it was the fulfillment of a centuries-old dream of humanity. The news became a symbol of hope, proof that we are not alone in this vast, cold universe. Others, on the contrary, called for skepticism, recalling past false alarms and pointing to the lack of repeated signals. This story clearly demonstrated how the information field works in the 21st century. Scientific news, not yet verified, turned into a global phenomenon in a matter of hours, becoming overgrown with rumors and speculation. The world held its breath, waiting for confirmation. All eyes were on the SETI community, an organization that had been searching for extraterrestrial intelligence for decades. They were the ones who would have the final say. To understand why a single radio burst caused such a stormy reaction, you need to understand how scientists think about extraterrestrial civilizations. Talking about little green men in flying saucers is the stuff of science fiction. Astronomers operate with more rigorous categories, and one of the key concepts in this field is the Kardashev scale. It was proposed in 1964 by Soviet radio astronomer Nikolai Kardashev. He realized that the development of a civilization can be judged by the amount of energy it is capable of controlling and using. This is a universal criterion that does not depend on biology, culture, or politics. Kardashev identified three main types of civilizations. Type 1. Civilization is a civilization that has mastered all the energy available on its home planet. This is approximately 100,000 times more than the current level of energy consumption by humanity. Such a civilization is capable of controlling the weather, preventing earthquakes, and using all the energy that its planet receives from its star. Humanity has not even reached this level yet. According to some estimates, we are at a level of approximately 0.73. Type 2 civilization is on a completely different scale. It is capable of capturing and using all the energy of its central star. To do this, it would have to build a gigantic astro-engineering structure, such as a Dyson sphere, a colossal structure that completely surrounds a star and collects all its radiation. The energy power of such a civilization would exceed ours by tens of billions of times. Finally, Type 3 civilization is the rulers of the galaxy. They control the energy of all the stars in their home galaxy, are capable of intergalactic travel, and possibly even space-time manipulation. This is a level bordering on the divine. And now, let's return to the signal from HD 166,495. Its power, assuming it was sent isotropically, that is, evenly in all directions, was colossal. To generate such an omnidirectional beacon that would be visible at a distance of 92 light-years, energy comparable to the total energy produced by the star HD 164,595 would be required. In other words, it would be a marker of a Type 2 civilization. Another possibility is that the signal was not omnidirectional, but a narrow, focused beam directed precisely at Earth. In this case, the energy required would be significantly less, but still trillions of watts, which would place its creators at the level of a highly developed Type 1 civilization. Both options were breathtaking. The idea that a civilization capable of building Dyson spheres or sending focused energy beams across the galaxy could exist in the Hercules constellation stirred the imagination. This was no longer just a search for life. It would be an encounter with something immeasurably more ancient and powerful than us. It was this theoretical background, this link to the Kardashev scale, that turned an anomalous radio burst from a mere curiosity into an event of planetary significance. At stake was something greater than mere confirmation of the existence of aliens. It was the prospect of encountering real space engineers. When news of the signal from HD 166,495,5595 spread around the world, it caused not only surprise, but also a state of heightened alert in one place. That place was the SETI Institute in Mountain View, California. SETI, which stands for Search for Extraterrestrial Intelligence, is not just an organization. It is an entire scientific discipline dedicated to answering one of the most fundamental questions. Are we alone in the universe? For decades, SETI scientists have been methodically listening to space, hoping to pick up that one signal that will change everything. And now, it seemed, it had arrived. But it didn't come to them. It came to their Russian colleagues. SETI's response was immediate and exemplary in terms of scientific protocol. The Institute's leading astronomer, Seth Shostak, became the main spokesperson for the excited public. In numerous interviews, he was both a source of enthusiasm and a voice of reason. He emphasized how interesting the target was, a sun-like star relatively close to us. He explained why the power of the signal made it so intriguing, referring to the same Kardashev scale. But at the same time, he constantly reminded everyone of the main rule of SETI. One signal is not a signal. It's just an anomaly. The key element for confirmation is repeatability. An alien civilization trying to make contact would most likely transmit its message multiple times to ensure it was noticed. Words were followed by action. The SETI Institute immediately mobilized its main tool, the Allen Telescope Array, ATA. Located in Northern California, this system of 42 parabolic antennas was specifically designed to search for artificial signals. Unlike RATAN 600, which scans the sky as the Earth rotates, the ATA can be pointed at a specific object and track it for hours, scanning millions of frequency channels simultaneously. On the night of August 28, 2016, all 42 ATA dishes turned toward the constellation Hercules and focused on an invisible point where the star HD 164,595 was located. The operation began. Simultaneously with SETI, other major players joined the search. Astronomers from the Green Bank Observatory in West Virginia, home to the world's largest fully steerable radio telescope, also announced their plans to observe the star. They were joined by Breakthrough Listen, the most ambitious initiative to search for extraterrestrial intelligence in history, funded by billionaire Yuri Milner. It was an unprecedented global mobilization of radio astronomy resources. Dozens of scientists and hundreds of hours of machine time on the most advanced instruments on the planet were devoted to checking a single 2-second burst. The world held its breath in anticipation. It was a decisive moment. If the signal was real, the powerful telescopes of SETI and their colleagues should have heard it again. If there was silence on the airwaves, it would be a strong argument in favor of an earthly origin or some unique, one-of-a-kind anomaly. The largest search for an extraterrestrial signal in history had begun. The night of August 29, 2016, at the Hat Creek Observatory, where Allen's telescope array is located, was tense. 42 antennas, working as a single giant instrument, were pointed at the star HD 164,595. The SETI observation process is not simply listening to the airwaves. It is a complex, multi-step procedure. The telescopes scanned a wide range of frequencies, from 1 to 10 gigahertz. This range includes the so-called water hole, the region of the radio spectrum between the frequencies of hydrogen and hydroxyl emissions, which is considered the most logical for interstellar communication because it is relatively free from cosmic noise. Computers analyze the incoming data in real time, filtering out known signals from satellites, aircraft, and terrestrial sources. Special algorithms were tuned to search for narrowband signals, those that do not occur naturally and can only be created by an artificial transmitter. Scientists paid particular attention to the frequency of about 11 gigahertz, at which the initial Russian signal was recorded. Hour after hour passed. The antennas tracked the distant star until it disappeared over the horizon. Then, the next night, the observations resumed. And another night after that. Astronomers collected a huge array of data, trillions of bytes of information. Then began the analysis phase, even more painstaking than the observations themselves. Scientists pored over the data, looking for any, even the faintest hint of an anomaly that could resemble the signal recorded by RATAN 600. On August 30th, Seth Shostak published his first report. The results were discouraging. To date, we have not detected any signals in the frequency range from 1 to 10 gigahertz, he wrote. Allen's telescope array heard nothing, absolutely nothing. The HD 164,595 system was completely silent. This was a serious blow to the alien beacon hypothesis. If a Type 2 civilization had used an omnidirectional transmitter, its signal would have been continuous, and ATA would not have missed it. If it had been a directed beam that just happened to flick past Earth in May 2015, the chances of catching it again would have been negligible. But even in that case, many expected to hear at least some background noise from the activities of a technological civilization. But there was none. Of course, this was not yet the end of the story. Perhaps the signal was transmitted on a different frequency, outside the range scanned by ATA. Perhaps it was intermittent and only turned on for short periods of time at long intervals. There were other observatories that had not yet given their verdict, but the first and fastest response from the most specialized instrument on the planet for searching for extraterrestrial signals was negative. Enthusiasm began to give way to skepticism. The air, filled with anticipation of a miracle, gradually cooled. The silence emanating from the constellation Hercules proved more eloquent than any signal. The negative result from Allen's telescope array was significant, but not definitive. The scientific method requires independent verification. What if there were some unaccounted-for features in the ATA's work? What if the signal was so weak that an even more sensitive instrument was needed? All hope now rested on two other powerful forces in radio astronomy: the Green Bank Telescope and the Breakthrough Listen project. Robert Byrd's telescope in Green Bank, West Virginia, is a true giant. Its 100-meter dish makes it the largest fully steerable radio telescope in the world. It is so sensitive that it can detect the energy of a single snowflake falling to the ground. In addition, it is located in the National Radio Astronomy Quiet Zone, a vast area where most radio-transmitting devices, including cell phones and Wi-Fi, are strictly prohibited to minimize interference. It is the perfect place to listen to the quietest sounds of the cosmos. Breakthrough Listen, an initiative launched in 2015 with the support of Yuri Milner and Stephen Hawking, is the largest project ever undertaken to search for extraterrestrial life. With a budget of $100 million over 10 years, the project leases time on the world's best telescopes, including Green Bank. Their signal processing equipment is state-of-the-art, capable of analyzing billions of frequencies simultaneously. It was the Breakthrough Listen team that took on the task of checking the signal from HD 164,595 using the Green Bank telescope. They conducted 3 observation sessions, each lasting 5 minutes, pointing the giant antenna at the star. Their strategy was slightly different from that of SETI. They focused on a wider frequency range, capturing the very 11 GHz region where the original signal had been detected. They looked not only for repeating signals, but also for any type of modulation or structure that could indicate an artificial origin. The results were published a few days later. The verdict was the same as Allen's: nothing. The Breakthrough Listen team found no evidence of a persistent transmitter in the HD 164,595 system. They analyzed the data with unprecedented sensitivity and found nothing beyond normal background noise. This was the second crushing blow to the extraterrestrial signal hypothesis. When two independent, highly sensitive instruments using different equipment and different teams of analysts arrive at the same negative result, it almost certainly means that the original observation was either a mistake or a phenomenon of an entirely different kind. The importance of this double-checking cannot be overstated. It demonstrated how the self-correcting mechanism of science works. A sensational hypothesis was put forward, and the entire global community immediately rushed to test it using the best tools available. Instead of blindly believing in a miracle, scientists subjected it to the most rigorous testing. And now everyone was waiting for the final word. The word from those who first started this story. What would the Russian astronomers at the RATAN 600 observatory say? While American telescopes reported silence in the direction of HD 116649595, the global scientific community eagerly awaited an official statement from the original source, the Special Astrophysical Observatory of the Russian Academy of Sciences, SAO-RAS. It was their RATAN 600 telescope that detected the anomaly, and it was up to them to put an end to, or at least add a few dots to, this story. The silence of Russian scientists after the information leak was understandable. They found themselves in a difficult situation. On the one hand, their data, which was not yet ready for publication, caused a global sensation. On the other hand, they themselves understood how high the probability was that the signal was of terrestrial origin, any hasty statement could either unjustifiably fuel the hype or damage the observatory's reputation. Finally, on August 31, 2016, the SAO-RAS published an official press release. The tone of the statement was restrained and strictly scientific, in sharp contrast to the media frenzy of the previous days. The statement confirmed that the signal had indeed been recorded on May 15, 2015. Its characteristics, power, narrow directionality, were unusual and deserved further study. However, this was followed by a key conclusion that put everything in its place. Subsequent processing and analysis of the signal revealed its most likely terrestrial origin, the document said. Scientists explained that on the day and at the time the signal was received, there was nothing unusual in the telescope's field of view. However, the specific nature of the RATAN 600 is such that it has a wide beam pattern, meaning that it simultaneously hears a large area of the sky and, unfortunately, part of the Earth's surface. This makes it vulnerable to interference. The most likely culprit was identified as a Soviet military satellite in an unpredictable orbit. Such dead satellites can sometimes turn on unpredictably and transmit signals that can fool even experienced radio astronomers. Yulia Sotnikova, a researcher at the SAO-RAS, was even more definitive in one of her comments. "We are almost certain that this was not a signal from an extraterrestrial civilization." This was the official verdict. The story that captured the imagination of millions for several days ended prosaically. There was no alien beacon, no Type II civilization. There was only a phantom signal from an old piece of Soviet space debris that happened to enter the telescope's field of view at the very moment it was looking at an interesting star. For the general public, it was a disappointment, but for science, it was a valuable lesson. The story of the signal from HD 166495 became a classic example of how the scientific process works. Recording an anomaly, proposing a hypothesis, global verification, and ultimately refutation. And although the mystery of extraterrestrial contact has been dispelled, another, no less important question remains. What are these earthly disturbances that can so easily mimic signals from extraterrestrial intelligence? The story of the signal from HD 164595 is, in essence, a story about noise. Not cosmic noise, but our own earthly noise. For radio astronomers, planet Earth is an incredibly loud place. We live in an invisible ocean of radio waves that we ourselves have created. And this ocean constantly interferes with scientists' ability to listen to the quiet whispers of the universe. What are terrestrial radio interferences, or RFI, radio frequency interference, in professional jargon? These are any radio signals of artificial origin that enter a telescope's receiver and mask or distort weak astronomical signals. Their sources are countless and varied. The main culprits are satellites. Thousands of active devices orbit the Earth. GPS and GLONASS navigation systems, communications satellites, television satellites, meteorological satellites, and military spy satellites. Each of them is a powerful radio transmitter. Their signals, intended for Earth, are billions of times more powerful than any signal we can hope to receive from a distant star. Sometimes a telescope accidentally gets in their main beam, and this completely blinds it. Worse, old broken satellites, like the one that was thought to be the source of the phantom signal, can behave unpredictably, turning on for short periods and creating unique, non-repeating signals. Another major source of interference is aviation. Airplanes constantly exchange data with the ground, and their radars scan the space around them. All of this creates a powerful radio noise. Then there are ground-based sources, cell towers, television and radio stations, air traffic control radars, power lines. Even in our daily lives, we are surrounded by sources of radio interference. Microwave ovens, Wi-Fi routers, cordless phones, even car ignition systems all create radio noise that can be picked up by a sensitive telescope. This is why radio observatories are built in places as far away from civilization as possible, in mountains, deserts, and special quiet zones where radio emissions are restricted by law. But even this does not always help. Radio waves can be reflected off the ionosphere and travel long distances. In the case of the Green Bank telescope, there was a famous story where scientists spent several years searching for the source of a mysterious interference that appeared every day at lunchtime. It turned out to be a faulty microwave oven in the staff break room, which employees used to reheat food. Dealing with RFI is a daily headache for radio astronomers. They develop complex computer algorithms to identify and cut interference from the data. They create catalogs of known signals from satellites so that they are not mistaken for something else. But there is always the possibility of a new, unknown source of interference that could be mistaken for an astronomical discovery. The signal from HD 164,595 was a stark illustration of this problem. It showed how easy it is to be fooled and how important it is to check and double-check your data. Before claiming contact with extraterrestrial intelligence, you need to be 100% sure that you haven't been talking to your microwave. When it became clear that the signal from HD 164,595 was almost certainly not a message from the inhabitants of this star system, but most likely terrestrial interference, most astronomers lost interest in it. The case was closed. However, there is always room in science for alternative, albeit unlikely, hypotheses. And one of the most elegant and intriguing theories that could explain this single, powerful, and unrepeatable burst is the theory of gravitational microlensing. To understand its essence, we need to turn to Einstein's general theory of relativity. One of its consequences is that massive objects, such as stars or galaxies, bend space-time around themselves with their gravity. Light from more distant objects passing near such a massive body is deflected from its straight path, similar to how light is refracted in a normal lens. This effect is called gravitational lensing. In most cases, we observe entire clusters of galaxies distorting light from even more distant galaxies, creating bizarre arcs and multiple images of the same object in the sky. But there is also a more subtle effect called microlensing. This occurs when a single, not very massive star is located in line between an observer on Earth and a distant light source, such as a quasar or another star. When this lens star passes directly in front of the distant source, its gravitational field focuses the light from that source, briefly and greatly increasing its brightness. To an observer on Earth, this looks like a sudden, unprovoked increase in the brightness of the distant object, which then fades just as suddenly. Now let's apply this to our signal. What if the signal was real, but didn't come from star HD 164,595? What if its source was some other, much more distant and possibly exotic radio source billions of light-years away? And star HD 164,595, along with its planet and companion star, just happened to be in the right place at the right time, in line with this distant source. In this case, its gravitational field could have acted as a giant natural lens, focusing a weak, constantly existing radio signal into a powerful short beam, which was detected by the RATAN 600 telescope. This hypothesis would elegantly explain all the oddities of the signal. Its enormous power, since it is an amplified signal, and its uniqueness, since such a precise alignment of objects is an extremely rare event that may not happen again for thousands of years. It would not be an alien greeting, but a cosmic mirage, a random play of gravity and light. However, this theory has its weaknesses. First, the probability of such a precise coincidence is extremely low. Second, a typical microlensing event lasts weeks or months, not 2 seconds. The short duration of the signal would require a very compact source and very fast movement of objects, which is possible but unlikely. Nevertheless, the gravitational lensing hypothesis remains a beautiful intellectual exercise, reminding us that the universe is full of surprises and that the most obvious explanation is not always the only one possible. The story of the signal from HD 1C64959 did not arise out of nowhere. It became another chapter in the long and dramatic chronicle of the search for extraterrestrial intelligence, full of false alarms, mysterious anomalies, and dashed hopes. To understand the context in which the events of 2016 unfolded, we need to recall the most famous predecessor of this signal, the legendary WOW signal. On August 15, 1977, the Ohio State University's Big Ear radio telescope picked up an extremely strong and narrow radio signal coming from the constellation Sagittarius. The signal lasted 72 seconds and was so powerful and close to the expected characteristics of an artificial signal that the astronomer on duty, Jerry Eman, looking through the printout of the data a few days later, circled it with a red pen and wrote a single word in the margin: "Wow." This exclamation gave the signal its name. The WOW signal had all the hallmarks of the One. It was narrowband, which is not the case with natural sources. It appeared and disappeared, as expected of a signal scanned by a telescope as the Earth rotates. Scientists immediately directed other telescopes to that section of the sky, and, as in the case of HD 164,595, they heard nothing. For more than 40 years, the WOW signal remained SETI's greatest mystery. Many hypotheses were proposed, ranging from terrestrial interference to a signal from an unknown astronomical phenomenon. In 2017, a theory emerged that its source could have been a comet passing through the telescope's field of view at that moment. The gas cloud around the comet could have generated radio emissions at the right frequency. However, this hypothesis is still disputed by many astronomers. The WOW signal remains a unique, unrepeated event. There have been other, less well-known cases. In 1967, astronomer Jocelyn Bell Burnell discovered perfectly regular radio pulses repeating at intervals of just over a second. At first, researchers jokingly named the source LGM-1, which stood for Little Green Men 1. It seemed so artificial that the hypothesis of an extraterrestrial beacon was taken seriously. However, other similar sources were soon found, and it became clear that a new class of astronomical objects had been discovered: pulsars, rapidly rotating neutron stars. These stories, like the story of the signal from HD 1C64959, teach the same lesson, as formulated by the famous astronomer Carl Sagan. Extraordinary claims require extraordinary evidence. Any unusual signal, before being declared contact, must pass through the sieve of the strictest skepticism. The most likely explanation almost always turns out to be either terrestrial interference or a previously unknown but entirely natural astronomical phenomenon. Each such phantom signal is not a failure, but a training exercise. It allows us to refine search methods, improve equipment, and develop more reliable verification protocols. And each such false alarm only fuels the excitement of scientists, reminding them that out there, in the depths of space, a real miracle may still be hiding. The initial rumor that formed the basis of our investigation spoke of the disappearance of a star. And although the story of HD 164,595 turned out to be related to a radio signal rather than a disappearance, the very idea that a star could simply vanish from the sky is not pure fiction. In recent years, astronomers have indeed encountered such mysterious events, and this is one of the hottest topics in modern astrophysics. We are talking about a phenomenon that has been unofficially named a failed supernova. According to the standard theory of stellar evolution, very massive stars, tens of times heavier than the Sun, end their lives in a grand explosion called a supernova. The explosion briefly makes the star brighter than an entire galaxy, scattering heavy elements into space, which then form new stars and planets. Either a neutron star or a black hole remains in the place of the star. However, what if the explosion does not occur? What if a massive star at the end of its life does not explode, but collapses directly into a black hole, quietly and unnoticed? In this case, we would see a bright star that had been visible in the sky for years simply disappear, leaving behind no flash or nebula. It would just fade away. Astronomers have several candidates for such failed supernovae. One of the most famous cases is a star in the dwarf galaxy Kinman, located 75 million light-years away from us. This galaxy was home to a very bright and massive blue variable star. Astronomers observed it from 2001 to 2011. But when they pointed their telescopes at it again in 2019, the star was gone. It had disappeared. Scientists checked all possible explanations. Maybe the star just dimmed significantly, but even the most powerful telescopes couldn't detect it. Maybe it was hidden behind a cloud of dust? But no traces of dust were found either. The most likely explanation left to astronomers is that the star underwent a complete collapse into a black hole, bypassing the bright supernova explosion stage. Another similar case is star N6946BH1 in the Whirlpool Galaxy. In 2009, it suddenly increased in brightness, as if preparing to explode. But then, by 2015, it completely disappeared from the visible range, leaving behind only faint infrared radiation, probably from matter falling into the newborn black hole. These events open a completely new window into our understanding of the life cycle of stars. They show that the universe has ways of getting rid of its most massive stars quietly, without fireworks. Each such disappearance is a unique laboratory for studying the processes of gravitational collapse and black hole formation. So, although the star HD 164,595 has not gone anywhere and continues to shine in the constellation Hercules, the mysterious disappearances of stars are not a myth, but a real and exciting mystery that the best minds on the planet are currently grappling with. Let's take a moment to step back from the great mysteries of the cosmos, signals and disappearing stars, and return to the HD 164,595 system to take a closer look at its only confirmed inhabitant. This is a planet officially named HD 164,595b. While its star is almost an exact twin of our Sun, this planet is the complete opposite of Earth. It was discovered long before the signal story, in 2010, using the radial velocity method. This method allows planets to be detected by observing tiny fluctuations in the movement of a star, caused by the gravitational pull of a planet orbiting it. Analysis of these fluctuations allowed astronomers to determine the basic characteristics of this world. The planet's mass is approximately 16 times that of Earth. This puts it on par with Neptune in our solar system. However, that is where the similarity ends. HD 1664595b belongs to a class of planets that astronomers call hot Neptunes. The reason for this nickname lies in its orbit. It is located at a staggering distance from its parent star, just 0.0223 astronomical units. This is almost twice as close as Mercury is to the Sun. A full revolution around its star, i.e., its year, lasts only 40 Earth days. Due to its proximity to a star that is almost as bright and hot as our Sun, the planet is subject to extreme conditions. Its upper atmosphere is heated to temperatures at which some metals can melt. Powerful stellar radiation probably strips the upper layers of the planet's gas envelope, creating a giant tail of escaping gas behind it, similar to a comet's tail. There is no question of a solid surface on this planet. It is most likely a gas giant consisting mainly of hydrogen, helium, and possibly water vapor, with a small rocky core at its center. Any form of life as we know it is absolutely impossible here. So why is this inhospitable planet so important? First, its existence proves that planets can form around a star similar to our Sun, and that they can be completely different from those in our solar system. This broadens our understanding of the diversity of planetary systems in the universe. Second, its presence does not rule out the existence of other planets in the same system. The dynamics of a system with a hot Neptune are complex, but they certainly allow for the existence of smaller, rocky planets in more distant and stable orbits, including in the habitable zone. Thus, HD 1666495b is a lonely but important watchdog. It is the first thing we have learned about this system, proof that it is not empty. And although it is a hot and turbulent world, it leaves hope that somewhere out there, in the cooler outer reaches of this system, another, more hospitable planet, a true second Earth, may be orbiting. So, the signal turned out to be a phantom. The aliens did not make contact, and the Sun's twin star remained silent. It may seem that this whole story is just a curiosity, a loud but empty sound, a misunderstanding, blown out of proportion by the media. But that would be too simplistic a view. In fact, despite its prosaic resolution, the incident with HD 164,595 became an extremely important and instructive event for science and society. First, it was a global test of the robustness of SETI protocols. What should be done if a potential signal is detected? How should it be verified? How should it be reported to the world? History has shown that the scientific community is ready for such events. The response was immediate. The world's leading observatories coordinated their actions and conducted an independent verification using the best tools available in the shortest possible time. This demonstrated the maturity and responsibility of the scientific approach. The procedure worked exactly as it should have. Secondly, this story highlighted the problem of radio interference more than ever before. It became a vivid illustration of how noisy our planet is, and how easily a signal from an Earth object, be it an old satellite or something else, can mimic something extraterrestrial. This prompted radio astronomers to develop even more sophisticated data filtering methods and to engage in closer international cooperation to track down sources of interference. The lesson was clear. Before looking for a needle in a haystack, you have to learn to ignore all the other junk in the haystack. Third, the public reaction to the news demonstrated humanity's enormous, inexhaustible interest in the search for extraterrestrial life. For several days, This scientific news overshadowed politics, economics, and sports. People around the world, regardless of their culture or education, were united by one idea, one question. This shows that the search for an answer to the question, "Are we alone?" is one of the fundamental, deep-seated needs of our species. This surge of public interest also helps scientists justify the need for funding for expensive projects such as Breakthrough Listen or the construction of new telescopes. Finally, this story is a lesson about the nature of science itself. Science is not a collection of ready-made answers, but a process of discovery full of mistakes, dead ends, and false alarms. The story of HD 164,595 is science in action, in all its unvarnished glory. It is a tale of how a bold hypothesis is born, subjected to relentless testing by the facts, and ultimately rejected in favor of a simpler but truer explanation. There is no tragedy or disappointment in this. On the contrary, this is the power of the scientific method, which, step, by eliminating the false, brings us closer to the truth. The signal has fallen silent, but science has grown stronger, and humanity has once again looked in the mirror to see its insatiable curiosity reflected back at it. The story of the signal from HD 164,595 has come to an end, but the search continues. It never stops. Every false alarm, every mystery solved, only strengthens the determination of scientists to continue listening to the silence of space. Today, this search is being conducted using tools and technologies that seemed like science fiction at the time of the WOW signal. The Breakthrough Listen project continues its decade-long survey of 1 million nearby stars and 100 nearby galaxies, collecting more data in a single day than any previous SETI project has collected in a year. Next-generation radio telescopes, such as the Square Kilometre Array (SKA) complex under construction in South Africa and Australia, will have unprecedented sensitivity. The SKA will be able to detect a radio signal equivalent to an airport radar from a star tens of light-years away. The search is also shifting to other areas beyond radio waves. Scientists are looking for so-called technosignatures, any signs of technological activity. These could be radio communications, but also abnormal infrared radiation from giant astro-engineering structures such as Dyson spheres, or the unnatural composition of exoplanet atmospheres polluted by industrial waste. The James Webb Space Telescope, with its incredible ability to analyze the chemical composition of distant worlds' atmospheres, has ushered in a new era in this search. It can detect not only signs of life, such as oxygen or methane, but also traces of chlorofluorocarbons, substances that do not occur naturally and can only be produced by industrial civilization. In addition, the very philosophy of the search is changing. Instead of passive listening, there are increasingly calls for active action, for so-called METI, messaging to extraterrestrial intelligence, i.e., sending messages to the nearest promising stars. This idea, however, is fiercely debated in the scientific community. Is it worth shouting in a dark forest without knowing who might hear you? Won't we attract the attention of hostile forces? This debate, known as the Fermi paradox. If there are so many intelligent civilizations, where are they all? Remains unanswered. We are on the threshold of great discoveries. Technology allows us to see further and further and see more and more clearly. We are not just looking for little green men. We are looking for the answer to the question of our own place in the universe. Are we a unique, fleeting phenomenon on a speck of dust orbiting an ordinary star? Or are intelligence and life universal laws? And is the cosmos full of thinking beings who, like us, look at their suns and ask the same questions? The signal from HD 164,595 was not an answer, but it was a reminder that the question has been asked, and humanity will not rest until it finds an answer. The search continues.